The diagram shows two circles of radius 7 centimeters with centers A and B. The distance AB is 12 centimeters and the point C lies on both circles. The region common to both circles is shaded. Show that the angle CAB is 0.5411 radians, correct to 4 significant figures. Find the perimeter of the shaded region and find the area of the shaded region. So I've got it summarized here then. First of all, this angle here, which is the angle from here around to here, isn't it, the angle A? Well, we can work out this one from Pythag, can't we? So let's call it alpha. This total distance is 12, and by symmetry this would be 6 and 6. So for part 1 then, just move that back a tad. So here, for part 1, cos alpha is equal to CAB. So cos alpha is equal to adjacent over hypotenuse, 6 over 7. So that tells us that angle CAB then, which is what we want, is equal to cosine to the minus 1 6/7, which equals, let's type it in the calculator then, shift cos, 6 divided by 7, we're in radians mode, not 0.5411, isn't it, to 4 dp. And that's the 4 decimal places, and that would be radians. Okay, part 2. Okay, find the perimeter. Well, here for the perimeter, angle A, well, we've got perimeter then of this shaded region is equal to this arc length plus this arc length. So it would be r theta, I'm going to call this r theta, plus another r theta, which equals 2r theta. R is 7, so that's 14 times theta. Now theta is equal to 2 lots of this angle, because we have, there's the angle there, and we just double it up to get this whole theta, 0.5411. So let's be accurate here. So 2 times this times 14, we're timesing it by 28 basically. So it's that times by 28. 15.15, 15.15, which equals 15.2 centimeters, and that's to 1 dp. Okay, that's the perimeter. Now we need the area. So part 3 then, the area of the shaded region is a half r squared theta, isn't it? Half r squared theta. That would be the area of the arc subtended by an angle theta. So that will give that whole area there. If we cut away this triangle area here, okay, so what distance is this? It would be this length here in the triangle is root 49 using Pythag, minus this squared is minus 36, which is root 13. So the total distance then from here to here is going to be 2 root 13, 2 lots of this. So half base times the height 6. So take away the triangle then, half base times the height 6. So that would give us the area of the difference between the arc sector here and the triangle cut away. But that's only half, that's only this side. We also need this side, which is just reflection and by symmetry, so it's 2 lots of this. So the halves can go, and we just get left with 7 squared, 49, times the angle theta, which is 2 times 0.541, right? So it's 2 times r, what have we got here? 49. Yeah, I've done the 2 times half is 1. So it's 49 r squared times theta minus, and then it's 2 of these, so it's minus 2 sixes are 12 root 13. So what have we got then? Let's tap it in the calculator. We're timesing by 2 and timesing by 49. So if we got ants, no, we don't want that one, do we? We want shift cos 6 7. So let me just type that in. 6 divided by 7. Okay, that's in the answer now. So it's, what was it, 98 times the ants. So it's ants times 98 minus 12, lots of square root of 13. 9.76 is what I get. 9.76 centimeters squared. So I'm just going to double check that, see if we're okay. Because it doesn't look too high, does it, for the area here? So I'm a bit worried about that. So let's have a look at it. So it's half r squared theta. R squared is 7, so it's a half of 49 times theta, this whole angle, which would be 2 of these, wouldn't it? 2 times this. So it's a half times 2 is 1. R squared theta, there's theta, minus a half base 2 root 13 times the height 6, half base times height. And then it's 2 of those. So we got 12 and we got 49 here. Theta. Yeah, I think that's okay.